the missile screams toward target, radar keeps on tracking. With electronic control, the computer automatically adjusts the missile to meet any change in the target flight. There is no escape. Intercept. This was a test, one of many successful tests of the Sage-Beaumark security team, our new system of air defense. To be ready for the worst, so that the worst will never happen, America is now armed with instant electronic reflexes. The Sage computer, made by IBM, is another example of the vast new powers that man can achieve through the creative use of his mind. Strength for national defense. Speed for informed decisions. Service for a...
Oh, hey, my mic's been on mute. It's fine. So we're looking for aircraft that aborted their landings. We're analyzing a few hours of real aircraft data collected in the West Coast, where aircraft are broadcasting their positions, altitudes, speeds, and we're looking for aircraft that aborted a landing. We're trying to test this hypothesis that during the FAA ground stop that happened January 10th, somewhat unprecedented, that it increased pilot and controller workload and distraction. And we're just looking for anomalies or maybe an increased rate of anomalies during that time. So right now I'm just running the code that the current state of the code for detecting aborted landings is that it seems to kind of reliably detect aircraft that are on final approach to a runway. So yeah, this worked here. This little Skyhawk was coming in on final approach, coming in lower and lower, landed. Let's check the third one. Yeah, it's seems a little late. Kind of fits the criteria. Oops, that's the same one. Okay, this is pretty good. I wonder if it's working better for faster planes than for slower ones. Uh-oh, is OBS using all my CPU? Is that why I can't click on a link? No, it's not too bad. Yeah, this is great, coming in at 140 knots. Uh-oh, what happened here? So this is an aircraft that was descending, starting at 33,200 down to 31,700. The other criteria are that it should be in line and close to an airport runway, which I don't see. Are we printing the runway? This was A2B810. A2B810. I think so. It was going to, is that Seattle? KSCA. Yeah, Seattle Tacoma International Airport, which is where? Nowhere near here. What's going on? What about this one? Okay, that one looks okay. Okay. So just doing spot checking, it looks like it is almost pretty good at detecting final approaches. There is this one anomaly in the anomaly detector. I don't know why it did that. Why did it detect this? Let's just review our criteria real fast. On final, so we call detect go-arounds. We look for, we call on, is it on final, which returns option, which contains the runway that it thinks it's on final for. So it's got to be above 0 altitude. Got to have some additional points, history, some additional states in the future that we can examine. The next state, we get the heading by looking just at the next state. Are we close to a runway right now? And I think the threshold for close to a runway is like 1 or 2 kilometers, something like that. Is the aircraft's current heading very close to the runway heading? And are we currently at least 200 feet higher than we're going to be in the future? At the, looking ahead 4 points in the history. So it's very simple, but it seems to actually mostly work. Oh, maybe, well, we could put in a minimum. I mean, you're not going to be on final at, 35,000 feet of altitude or whatever. So we could say something like your current altitude has to be above 0. And it's got to be less than, I mean, what happens if we say 1,000? What about, let's check some of the ones. So we would filter this one out, hopefully with that criteria. What did we say? The 2,000? Okay, so we'd catch this one. Catch this one, 1,350. Catch this one, 1,000. Same one. Catch this one at -275. So actually, why did we have a condition that the altitude has to be greater than 0? So how did this one get in here? 0. This is the very first one. Well, let's run it again, see what happens. So we've just added this additional constraint. Altitude, initial altitude here has to be less than 2,000. And let's just stop it there. We got a bunch here. Okay. Looks good. So I don't know if this is a display issue with ADSB exchange or what. Checking the URL here. I mean, ADSB exchange has the right, it knows about this aircraft, it's got the right position. Show trace date, start time and end time look okay. What if we, so what is this, Eugene Airport? What if we, oh, it's already, yeah, that's weird. What's up? I mean, this is a little weird. It's, so if you look at the next day, that's perfect. So there's some sort of weird date thing going on. Why does it work for all the other aircraft, but not this one? Well, I'm not going to worry about it too much. I still don't know how this one got in because the altitude is, well, I suppose it's possible just before this there was a data point that was above 0 feet altitude. I mean, yeah. Just go back 18 seconds. So I think we'll just say that's close enough. Okay. So we're getting, for now, we'll just accept this as a good enough on final detector. Then we want something that tells us that it didn't take off, or that it didn't land. Right? Yeah. I don't think this is going to be right. This is a GitHub Copilot suggestion. I mostly took it just for the function signature. All right. So I think for didn't land, let's just try. What if we just say so we have to know that it didn't land, so there has to be at least let's look ahead 30 points. Let's look ahead 100. And we'll say what is the We want to slice from I to something like that. Yeah, that's close, right? Get rid of all this. This is really just going to return a Boolean. Why don't we look at 200? What's the formatting of this? Spaces. Run a little quick cargo format. Ooh, what do we got? This. Okay, let's just finish it out. So we'll say it landed if at any point in the next 200 data points altitude is 0 or ground speed is 0. Kind of seems about right. We don't care about runways. We don't need the aircraft hex. Now we reformat. Looks nice. Okay. What's wrong? Oh. After we reformat, the warnings are in the wrong place because we didn't change it in VS Code. So I just save it in VS Code to force the Rust analyzer to run again. Okay. So if we're on final, yeah. If we're on final and it didn't land, let's just see how that works. Kids are in bed. Got my tea, my lemon ginger tea. Went to Echo Park Lake today. Rode in a swan boat. Didn't expect that. It was fun. Aria was a little scared. She's 4. And, we haven't really done things like ride around in a swan boat a lot past 2 years. She has done it at least one or two other times, but she's 4 now. She's a little more aware of danger. So this guy, why is this here? It did land. It's on the ground. So why did it show up? Let's look at some other ones. Just love debugging. Okay, so this, maybe, is it that other? Yeah. Don't know why it happens, but I know how to work around it. But these guys are all on the ground. Mm-hmm. Let's just do, whoops. Let's check to see where it thinks it is. Did we mess up the logic here? So we consider it landed if any of these states in this span of history has altitude 0 or speed of 0. So it did land, if that's true. Oh, yeah, I see. Well, so maybe there just wasn't any more future points that would, yeah. So we say this. Might be right. Yeah, see. Okay, that's exactly what we would expect if that was the problem. Because our little debug print here tried to look 200 points in the future, but it didn't exist. And that's why this wasn't working correctly. Okay, that's good. Didn't take too long to fix. Saw a lot of geese at Echo Park Lake. There's still the weird thing where there's a fence up around the entire lake. And for a while, it was like an anti-homeless encampment measure. And for a while, you just couldn't go in and use the park. But now the fence is still all the way around the lake. Chain link fence, but now they have openings. Oh god, now we're not going to find... Okay. I mean, I guess it's good that it didn't find anything yet. Implying that it really is looking for aborted landings. With the rejected takeoff, it was perfect because I knew there was at least one rejected takeoff, so there was a positive example. The code had to find it or it was broken. And we did find it. Here, oh, we got one. Oh, I'm very excited to click on this and see what it is. Oh, well, right. We didn't really put anything in here to see. We didn't really put anything in here to filter out touch and goes. So I expect that we will see those. What am I doing? I was trying to put my phone on this stand, not have it fall over. Probably need to use a little spit on the suction cup. Okay. Zoom in, zoom in. What's going on here? Oh, God. Well, what the hell, man? Why did this get chosen? What can we do to get rid of that? So somehow it got through the on final filter. I mean, basically, if it finds any point where altitude is above 0, but below 2000, lined up on the runway. But there's got to be a future state where, a future time where it is 200 feet lower. So how did this do that? What if we... look back another minute? Look forward another minute? Oh, sorry. We did put. I said that we didn't put anything in a filter out touch and goes, but we did. Because we look 200 points into the future and make sure that for all of those, it is not stopped or on the ground. So a touch and go would be on the ground at some point. I assume this is running at 100% CPU. Yeah. 90. So while it's churning through that history, I'm trying to figure out why this one got through. It's odd. I mean, it even... What the hell? Look at this. Jeez. So it printed out the projected take. Oh, wait, what? Am I still printing the wrong thing? I'm just wondering why it says rejected takeoff. I think I'm just... Let's detect rejected takeoff. Are we still calling? Oh yeah, we are. Okay. That's weird. Should I speed it up? Should I interrupt it now and speed it up by not calling detect rejected takeoff and just detect go arounds? And is it time to perhaps filter out? Currently, it's looking at it, every point is being, well, not every point within the altitude, allowable altitude, which is a lot of them. We're computing the distance to every runway. Less. Let's just take a look here real fast. I mean, there's a lot of kind of weird edge cases that are possible here. Like close to runway just returns the first runway that we're close to. And then we check the heading of that runway. You could theoretically be close to two runways. You're landing on one, but not the other. Oh, well, actually that would happen. That could easily happen if you are landing at an airport or on approach to an airport that has non-parallel runways, more than one runway. So let's let us change that. Close to and in line with. And we'll, that's right, we'll pass in our heading. So we have our distance. Oh, God. Heading normalization, forgot about that. Heading diff, runway heading. I like to put units so you never have to ask, what unit is that? Is it radians or degrees? Okay. So this, we'll do the right thing now. I think it'll search all known runways, and look for one that is close and has the right heading, and it won't stop too early if it just finds a close one that doesn't have the right heading. No, we're not writing our bane, we're writing heading diff. I kind of hate, oh, this is going to be something where Copilot does a great job. Well, I mean, not exactly. Oh, was I not even calling absolute value before? Probably not. So that's another reason it wouldn't have worked very well. Yeah, this isn't bad. There's still a question of are the headings normalized in the same way? Like, I mean, I'm just going to assume there's not like a heading of 720 degrees, which would cause this to fail. Let's just see what happens now. And yes, let's turn off detect rejected takeoff. So let's think about kind of the worst case here for a heading diff. Minus 180. If A is minus 180, B is 180. We get negative 360. Absolute value is 360. Yeah, if diff is more than 180, ends up being 0. Yeah, that seems about right. Well, just for debugging, we loosen the didn't take off or didn't land. And just check a few of these things. So now we should see a bunch of stuff on final approach, but we'll just check to make sure they really are on final, plausibly on final, before we let it churn through everything. And should I do some freaking progress display, I guess, you know. You got a panic, really? Interesting. Oh. Yeah. Let's just comment that out for now. Because our didn't land check will filter out anything it doesn't have at least 200 more data points. Once we commented that out, we no longer had that guarantee. I've been looking for a camera. Now we have, okay, almost 7,000 aircraft. I've been looking for a camera to run the IQT Labs Skyscan software, which is the automatic aircraft camera tracking. Aims a pan tilt zoom camera at aircraft based on their ADS-B info. But you need a good camera. You need one that supports the right pan tilt zoom commands, has a high zoom. At least that's what I want. Okay, that looks right. Kind of hoping we'll see. What's this? Kind of hoping we'll see something on at an airport with multiple non-parallel runways, just to confirm that it's working the way we expect. No, it's not the worst. Okay. And let's put back, first of all, let's change that to every 100. Print a little progress display. Put this back. Okay. And also let's start looking at how to filter out runways that aren't on the West Coast so we don't bother checking to see how close we are to those. Too bad California comes so far east like that. So let's maybe a -113 longitude. So it's got to be less than -113. Yeah, see, look at this. It's taking so long to do 100 aircraft. Yeah. So, what do we have, like process runways? Oops. After geofiltering, its position. What is position? Probably longitude. No, we can't index into it. Oh, it's X and Y. Okay, this could be a nice speed up. Let's see. Oh, something's wrong. Okay, now what? What? Really? No. Yeah, okay, right, because it's just a totally new thing. Someone knows what it is. Someone knows the type, but sure. I forget what the deal is. I always run into this and I forget the easy solution. How do we... Okay, it's time to Google. Rust collect, don't want reference. Right. Cloned, that's it. At least I seem to remember doing that before, so I'm hoping it will fix it right here. Yep. Oh, yeah. So we filtered out 90% of runways. Oh god, it's still slow. Honestly, now I'm wondering if... we're gonna parallelize it with rayon. We'll run it on every core. That'll really... oh god, OBS will hate that. Seriously? We still haven't even done 100 aircraft? Did I do something wrong with that? just see. Yeah, we don't have that many cores here to use, really. Oh man, now we gotta wait for it to... Oh, you're gonna use a new crate? Cool, let me analyze it. I just want to run my code. Okay, meanwhile, let's just... RAN's been very easy to use when I've used it before. Well, that's basically what we want right there. Stream is going to grind to a halt if I do this. Is it just parallel iterator? Yeah. Yeah, come on. What? Come on now. I didn't mean to do that. That's what I meant. It's not going to matter. We're going to take that out in a second as soon as we use RAN, but I just want to see how long does it actually take to process a single aircraft. And can we just let's just make it super simple, because I can make any mistake. Any possible mistake, I can make it. I will make it. Okay, that's more like it. So some dumb mistake. Operator precedence or something, yeah. Okay. So when we do... Okay, let's just try it. Can we still enumerate? No. Why does my phone volume just go up on its own sometimes? Golly. Well, let's forget about enumerating. I said, let's forget about enumerating. Now what? Only the last element of a tuple. Oh, because it's a hash map? I see. like this. Okay, well, forget it. We're not going to use Rayon right now. Just going to do that. We are going to enumerate. Why? Who said that we weren't going to enumerate? What's this about? Yes. Has this warning always been here? What did you do? What's happening? Sure. You know what that was? Because I've written a VS Code extension that has the same issue. So I ran 2 code actions. So those little green squiggles. Hit save. You'll see 2 little green squiggles. So these are diagnostics in VS Code extension terms. They have quick fix code actions associated with them. Now the problem is Rust Analyzer is not going to regenerate and those actions. So the actions specify positions in the file to, well, they specify edits based on positions in the file. So it's basically saying, you know, the code action here is just to delete this ampersand at this position in the file. So it's not looking for an ampersand, it's just the absolute character position. So if I run this one, okay, that's cool. But now this code action has not been regenerated. And so it's actually saying delete. I mean, I don't know why I deleted this. Let's just see what happens. It's basically going to delete the wrong character. Yeah. I don't know why I deleted that. That was weird, but same problem in my extension, except my extension usually recalculates everything on every keystroke, so it happens a lot less often. Okay. Dude, running a VS Code extension is a lot of fun. Yeah, this is for my work at Imagineering R&D. I use Tree Sitter and Rust. Tree Sitter is a parser generator that is extremely error tolerant and is extremely fast and supports incremental parsing. It's awesome. That combined with, well, I use it in a Rust language server that talks to the VS Code extension, and it's just great. It's super fast, it's powerful, it feels sometimes like a superpower. Okay, so that's not too slow. Yeah, see, we didn't need Rayon. We're just going to run through all 6,700. I think we'll probably call it a night at that point. It's 9:27 p.m. in Los Angeles, California. I finished my tea. I have a first cut at go around detection that doesn't have any obvious bugs. If you think it has an obvious bug, you should have been watching this stream and telling me in chat how dumb it was. I was totally broken. But you're not, so this is what we get for now. So theoretically, if you write a language server, you can use it with other editors besides VS Code. It's a pretty common pattern, I guess, for VS Code extensions. The Rust Analyzer extension does that. A bunch of others. And I do have Rust Analyzer set up in my Emacs. I'll show you while this is running. let's hop over to Emacs. It's a little, it's not, the integration in Emacs, maybe it could be done better. I don't totally love it, but it's okay. I would kind of hate to have to write Rust without Rust Analyzer. So I have to have something if I'm going to do it in Emacs occasion. And I do use Emacs sometimes. For certain kinds of editing, I just feel more comfortable in Emacs. We are CPU limited. Yeah. Yeah, it's running the Rust language server, RLS. So it's going to take a minute. We'll see which finishes first. Is RLS going to finish analyzing this in Emacs, or is our program going to finish processing all 6,700 aircraft? Okay. So I guess could there be a go around that we didn't detect? Yes. But I kind of think we're doing a decent job. Maybe I'll do just one last thing. What if we change our didn't land condition to be just ground speed 0? Let's just see what happens. So now it doesn't care if you're on the ground. You have to have stopped. So that's not a very good check because once you're on the ground, it's kind of hard to pick up the ADSB broadcasts. Generally, the higher you are, the easier it is. Fewer obstructions to whatever receiver is picking it up and sending it to ADSB exchange. So it's kind of not super likely we will always be able to track an aircraft to the point where it is stopped on the ground. But let's just see what happens. Let's check Emacs here. Anything? Okay, there we go. Oh, yeah, make it bigger so you can see it. Well, you can see some of it at least. Does it give us any warnings? Is it using fly make? I forget. Fly check? Yeah, fly check. Oh, so it's giving us the right warnings and stuff. Okay, back to VS Code. So what's this? This is just someone taxiing and they stopped. Well, maybe we didn't see when they stopped. Okay, let's check another one. There's a lot. Oh, we're seeing aircraft that have basically stopped. I was kind of hoping I'd see go-arounds, but yeah, they might have to stop to let some other traffic go by. Okay, I guess this is what we would expect. Definitely have a landing detector. Did this guy really stop? Is that as much as we can zoom in? No. All right. Well, I'm kind of convinced. I think it did the right thing. I think we don't have, I'll say 90% confident that we don't have a go around. So I guess I think that's it for looking for anomalies during the ground stop. And I'm a little curious about maybe just running these anomaly detectors on the ADSB exchange data live and kind of looking in real time for projected takeoffs and go arounds. So I might do that. That might be the next thing I try streaming. But I think for now we're done with the ground stop anomalies. Resume normal ops. Sorry for the scare. And good night.